without further ado, I would like to introduce Dr. Timothy Chung, who is the program manager for the Darpa SubTChallenge. And Dr. Chung joined Darpa's Tactical Technology Office as program manager in 2016. He serves as the program manager for the Offensive Swarm-Enabled Tactics program and the Darpa SubTChallenge. And his interests include autonomous unmanned air vehicles, collaborative autonomy for unmanned swarm system capabilities, distributed perception, distributed decision-making, and counter-unmanned system technologies. Prior to joining Darpa, Dr. Chung served as an assistant professor at the Naval Postgraduate School and director of the Advanced Robotic System Engineering Laboratory. His academic interests included modeling, analysis, and systems engineering of operational settings involving unmanned systems, combining collaborative autonomy development efforts with an extensive live-fly field experimentation program for swarm and counter-swarm unmanned system tactics and associated technologies. Dr. Chung holds a Bachelor of Science in Mechanical and Aerospace Engineering from Cornell University. He also earned a Master of Science and Doctor of Philosophy degrees in Mechanical Engineering from Caltech. Now, on the Eventbrite, there were links to the SubTChallenge and to the Darpa pages where you can learn more about it. We'll be putting those links into the chat as well, and we will be providing everybody with contact details and information links where they can follow up after this. But I am very pleased to hand over now to Dr. Chung, who will explain what the SubTChallenge is about, what has happened to date, and most importantly, how we can all still get involved with it. So over to you.
Yeah, great. Thank you, Andra. And thank you to SU Robotics. I appreciate the chance to engage with you all. I'm particularly pleased given that I spent a fair bit of time, as you heard, out there on the West Coast, and SVR is relatively near and dear to my heart, so I appreciate the chance to come back and share this with you. As Andra mentioned, I'm Tim Chung. I'm at the Defense Advanced Research Projects Agency, and one of the fantastic opportunities that I have is to be a part of that grand challenge legacy. Many of you in robotics may be aware of the longstanding tradition that Darpa has had with the Grand Challenge and Urban Challenge for self-driving cars, all the way to the Robotics Challenge for safe search and rescue. And now we have, in that long line of challenges, the Darpa SubTChallenge, which I'm so thrilled to be able to share with you today. So before we get in, I think I just want to set the stage. What we're doing here is always looking to develop and inspire breakthrough technologies and capabilities that will help in a number of different areas, whether that's in civilian or defense applications, ultimately trying to help save those lives of people who are out there doing dangerous things. So I'm speaking to an audience, of course, that's quite familiar with many of the applications of robotics, and the subterranean environment is one such environment where I think we still have a lot to learn. So with that, let me showcase what we've recently done at the Darpa Subterranean Challenge Urban Circuit with this compilation video.
This is a very exciting experience. So many good teams from all around the world.
This is a way to be challenged and to learn things.
Are we up to the task? Can we use our existing technology, our existing expertise?
A lot of the world is going to end up having these fleets of robots. It's very exciting to see all these various and different technologies that are state-of-the-art.
The SubTChallenge for us represents everything that relates to how we can make robots to be resilient in extreme conditions.
This is kind of a step up for us, even bigger of a challenge than we faced so far.
It sells to all robotics, make sure that your robots are able to do their mission. This is absolutely difficult at the moment.
And so what we were able to just showcase there was an opportunity at what we call the urban circuit, which I'll describe here shortly, where we assemble teams from all around the world to bring their robotic systems, and they faced basically an unfinished nuclear power plant as they conducted the urban circuit competition events. And so I'll describe the structure of the Darpa SubTChallenge here in a minute, but let me paint this picture for you. I think one of the really interesting things about the SubTChallenge, and many of you who've experienced going out there and trying to test your robots outside the lab, you know that it's very dependent on where you test, how you plan for that environment. And one of the things about the underground is that it's just so unknown. There's so many variables down there that it's hard to anticipate, and you really have to not only bring your A game, but the set of robots or the types of technologies that you need to bring to bear really dramatically impact how well you can do things. And so here in the SubTChallenge, we're interested in not just one type of an environment, but in fact, multiple types of environment to really stress test the types of robots that teams can develop. In particular, there are 3 underground environments called the tunnel, urban, and cave environments, where a set of robotic technologies might work in one, or maybe 2, but not necessarily all 3. We like to describe it in the context of a triathlon. You know, you may be a good runner or maybe a good cyclist, but to be the best triathlete, you have to be able to accomplish all 3 of those types of things. For the SubTChallenge, we also have a systems and a virtual competition, and I'll describe that in greater detail as we go along our talk this afternoon. But at the end of the day, we're interested in robotic technologies that can go into these unknown underground environments and do meaningful, actionable things that will help save human lives. There we go. And so, as I highlighted, we just concluded a few months ago that urban circuit in February that was conducted out in Elma, Washington, at an unfinished nuclear power plant. We held the tunnel circuit in the summer of last year at the NIOSH mines. It's a inert coal mine. We have the cave circuits coming up later this fall. And at the end of all of that, we're interested in that triathlon event where we have a final course that takes elements of all 3 of these subdomains and brings them all together to really challenge the robotic systems that are brought to bear. And so what is it that we're trying to do? We're really interested in being able to provide rapid and actionable situational awareness in these complex underground operating environments. And what do we mean by that? Well, it means that we don't want to just know that it's there. We want to know what kind of information that an emergency responder or an incident commander can make use of as he or she plans out how to conduct that rescue mission going into these really challenging and dangerous environments. And one of the things that we've learned by engaging with, for example, the fire department in New York or the mine rescue community is that each environment is very, very different. And so what might work in a tunnel, out there on the West Coast might not work for a subway station out here on the East Coast. And that diversity, even though they're all underground, is what's still an open challenge, I'd say, for field robotics writ large. It's the fact that we tend to develop solutions really understanding the niche problem, but then when we try to translate it out to other arenas, other operational environments, they often falter. And so we're really interested in the SubTChallenge of not just finding the best positioned player on the team, but in fact, the best all-around athlete when it comes to robotic systems. And we are doing that through exercising these robotic systems in human-made tunnel environments, such as mines, urban underground settings, as I alluded to earlier, as well as naturally occurring cave networks, where cave search and rescue turns out to be an incredibly challenging and trying application area as well. And so just to scope it a little bit further, we're interested in this scenario where we span a number of different contexts. And so in particular, we're interested in those environments where you don't know how the lay of the land might have changed. So these are unknown environments, changing environments as time goes on, and it's quite unsafe to send in rescue personnel as the first go. And in particular, there is the spectrum of type of applications. And on the one hand, you might have types of inspection missions that we know robotics can be applied to, or scientific discovery missions. But there, even if the risk is somewhat elevated, we can take our time. We can be deliberate in our planning, and oftentimes you have weeks, for example, to plan out that mission to do the scientific data gathering. On the other hand, when a crisis has hit and we need to send in our first responders immediately, there's that period of time where it's, you only have T-minus minutes before you can really respond. You accept the risk to those personnel, and it's an intervention mission that must be undertaken. And so the SubTChallenge is focused in that sweet spot middle area where oftentimes when an emergency operations center is being stood up, you have 1 to a few hours before we're going to send any people in. It's in that time window where you're gathering information in a search and rescue mission that we could send in these robotic assistants, if you will, robotic scouts, robotic agents to go and get a better lay of the land and return, again, that actionable situational awareness, information that that incident commander really needs to help plan out what people to send in, what equipment to send in, where to send them, and how to do so effectively and safely. So in that problem space, we have a number of things that you can imagine these 3 different arenas, these 3 different what we call subdomains, sharing in common, and things that they're markedly different. And what we're interested in are those technologies that will transcend those differences between these subdomains and allow for meaningful impact for that search and rescue mission we just described. So when you look at these underground environments, tunnel, urban, cave, there are a lot of common characteristics. A lot of them are captured here on the slide. We can't see around every corner or every bend in the tunnel. You never know if that air down there is breathable. That's one of the major challenges of underground settings. The communications in terms of radio frequency propagation, things like Wi-Fi, certainly GPS absence, really hard to deal with the unpredictability. And so a lot of these features are common to all of these, all 3 of these subdomains, but then you get to see how exactly the different subdomains stress test our robotic systems. We might have environments that have really long kilometers in length scales, or other arenas where you have incredible verticality, where certainly ground-based robots will certainly be challenged. Twists and turns, where of course localization and mapping will now be stress tested. And as I already mentioned, the absence of GPS, the no guarantees that the environments are lit, certainly not even sure that they're entirely traversable. These are the types of characteristics that we're interested in accentuating in each of our subdomains. And we believe that by stress testing each of the robotic competitors in this way gives us additional insight in how to build that all-around best athlete or best team of athletes that'll be impactful in the future. And so I thought I might start off a little bit with some open questions. These are the kind of the big picture questions that we'd love to be able to answer. And I know many of us on this call here share some of these questions. So, if you had to compose a team of robots, how would you take advantage of the mixed platforms or sensors that you have available to you? What kind of information do you need to know? Would you like to know when you're building out that team? How do your robotic team members deal with the fact that you might not know what they're going to face, and that danger could even be loss of those robotic platforms, or maybe separation from robotic team members? How is the autonomy, for example, going to help you overcome some of those problems? And so for the SubTChallenge, we're interested in 4 key technology areas that are certainly recognizable to all of us on the call, involving autonomy, perception, networking, and mobility. And it's not about solving just one of these problems, but in fact, the Darpa Subterranean Challenge is about the systems problem of bringing all of that together. How do you integrate an autonomy solution that's understanding of the networking challenges, or the mobility approaches that will allow for you to be clever about how you perceive the environment, as an example. And so here we have a number of different measures, technology measures that we're interested in. But again, it goes back to those questions, those open questions that we're really deeply interested in solving. And so just for fun, let me throw out a couple more based on these 4 technology areas. Given that these environments are somewhat unpredictable and you never know what you'll encounter in terms of smoke or lighting, type of terrain, etc., how might you use different sensors to really help you accomplish your mission? What kind of comms modeling can you do up front, especially when these environments are so hard for radio frequency technologies? I think there are other times where you need to make a decision, or the robots need to make a decision when they need to gather more information in an exploration context, or other times when they need to go and drill deeper. Hey, is that a dead end, or is that an opening to another segment of the environment? So that explore versus exploit trade-off, I think, is a critical one. And then finally, this is one that's kind of hard to bake in, I think, but when should a robot give up in terms of when it knows its limits, and when should it try a little bit harder, meaning try again, get up and pick itself up? I think these are really interesting questions, especially when these robotic systems are particularly challenged with these difficult environments. And so let's get to what the SubTChallenge problem actually is. We're interested in an actionable situational awareness, again, in these underground settings where you don't have access to GPS and reliable communications and such. And when we say actionable, we're interested in finding these objects of interest, these artifacts as we call them, to within 5 meters of global position error. And you need to be able to report what those are correctly. So I have a video here that'll kind of detail what this is. Here, let's get that going.
Here's how to win an event in the Darpa Subterranean Challenge. Find the most artifacts in the shortest amount of time. When, or if, a team's system locates an artifact, it has to report not only the type of artifact, but also its spatially referenced location to an accuracy within 5 meters. A valid report earns 1 point, but teams are granted only a limited number of reports, so they can't just guess until they get lucky. Sounds easy enough? Think again. Teams have to send their systems through dynamic terrain, over, under, and around obstacles, in austere navigation conditions, pushing the limits of their endurance, and in conditions degrading sensing capabilities and severely constraining communications. Teams will be permitted multiple timed runs through the course, but between each run, the course can be changed. Obstacles added, passages blocked or unblocked, and artifact locations can be changed. So teams need to be agile, adaptive, and accurate if they want to emerge victorious in the SubTChallenge.
And so in that context, what we are highlighting here, that it's not just about building a map of the unknown environment. That's very important, and that's still critically enabling technology, but we want to do more than that. And this came about from talking, for example, with the fire department of New York saying, hey, we don't want to send in our firefighters to any false alarms. That not only takes time away, the very valuable and precious time, but also puts those firefighters, those first responders, at additional risk. And so getting precise locations as well as correct classifications basically renders the SubTChallenge as a massive underground scavenger hunt where we're asking robots to go into environments that they've never mapped or seen before and find these variety of artifacts down there and report them back to the incident commander, given all of the challenges that we've just talked about in terms of scale, difficulties in communications, different types of terrain, etc. And so to lay that out, we have 2 ways that we're driving some of that innovation. The first is in the systems competition, where we go to actual locations and instrument these courses and bring competitors from all around the world, like we showed at the beginning of the talk. At the urban circuit, we had 10 teams converge on the SATSOP business park where there's an unfinished nuclear reactor and nuclear power plant. The teams had never seen the lay of the courses before. They didn't know how many levels there might be, and how many twists and turns, how many rooms they'd have to go explore. They're only allowed one human supervisor to sit in the staging area, manning that human supervisor's base station, and then the pit crew is there standing by to help service and work with the robots as they go in and out of the course. And as these robots move into the course, they're oftentimes appropriately mapping the course as well, like you can see on that upper right-hand side. But they have to report back artifact locations to within that 5-meter ball, as I mentioned earlier. They do that successfully, they get a point, and they have about an hour to go and do that. And the team that's able to find the most artifacts underground in that time is able to take home top place. We also have the virtual competition, which I'll spend some time talking about in greater detail here today. But this mimics the systems competition in the sense that we're interested in having robots explore previously unknown environments. And now we can take advantage of the virtual synthetic capabilities that technology affords us now to build out different types of environments, explore different types of robots with different types of sensor payloads. So a competitor now can develop the autonomy and perception, the software-based solutions, develop that, roll that into a Docker container, upload that into our cloud-based simulation environment, and play out their approach to see how well it fares against those hidden, unknown competition worlds in the context of the virtual setting. And so you can see that we're interested in seeing how the virtual and the systems competitions can play off of one another to really help accelerate some of the tech development that we're interested in. And just to highlight how that's structured here, we have, as I mentioned, we're now at that cave circuit leading up to that in the fall of this year. We've conducted previously the tunnel and urban circuit. And so what you can see here is that these circuit events are spaced approximately 6 months apart. And that's not enough time for any robotics team to go and do a clean sheet design for each one of these subdomains. So the intent behind this all along was for teams to think through the types of robotic systems that they'll need, types of sensors that they'll need, the type of autonomy and perception that they'll need to be able to really conquer all three of these subdomains. And it's really that holistic perspective that we're interested in the SubTChallenge. So upon conclusion of the cave circuit, I'll give all teams in the systems and virtual competitions some time to maybe lick their wounds or learn from their lessons as they march towards the final event. And in this case, we'll have a epic grand finale course, as well as the comparable audacious scale and scope for the virtual competition courses as well. And this is where teams are eligible to win up to $2 million in the systems competition and $750,000 over on the virtual competition. And so to highlight that virtual competition, because I see our community here at SVR, that virtual competition being one of those places where I think if you're an individual who has some familiarity with robotic software development, all the way to a university team or a high school robotics club or whatnot, you really get a chance to play and learn in the virtual competition. So I want to share a little bit more about this virtual competition to SVR.
The Darpa Subterranean Challenge virtual competition pushes the limits of autonomy by challenging simulated robots to explore virtual underground worlds. To win, competitors must build software to drive or fly simulated robots through the virtual worlds, gaining points by locating hidden artifacts that represent items that first responders or service members could encounter underground. The worlds are designed with obstacles, constrained passages, vertical elements, and degraded communications. The worlds mimic real tunnels, urban infrastructures, and natural cave networks. Tiles can be used to build new environments. The scale and diversity are limited only by your creativity. The robot teams must navigate through these challenging environments completely autonomously with no human interaction. Competitors build their robot teams by choosing from the platforms and sensors on the SubTech repo. They can build teams of multiple robots, though they must choose wisely. Each item has a value in SubT credits, and competitors only have 1,000 SubT credits available to build their teams. Virtual competitors then add software to each of their robots to autonomously map, navigate, and search for artifacts in the simulated environment. That's how teams take on the SubTChallenge virtual competition and revolutionize how we operate in the underground domain. Are you up for the challenge? Get your team ready and enter today to compete.
Yeah, so that overview highlights a number of the different pieces of the virtual competition where I'm really excited for the robotics community to be able to more fully engage in a couple of areas. And so the first that was mentioned there is the SubTech repo that's highlighted at that URL. And this is essentially, I like to liken the systems competition to, let's say, the National Football League. So you're watching football, you have your team, you pick out who your lineup is at the beginning of the season, and you play with that team throughout the entire season. The virtual competition is like your fantasy football teams, right? You get to go and pick and choose. You have a salary cap, so 1,000 SubT credits. You get to go and pick and choose which robots you'd like to bring into the competition at each stage. And you pick and choose based on what you think you might need in terms of ground robots versus air, LiDAR versus cameras versus gas sensors or other things. And the SubTech repo gives you that opportunity to go and explore a variety of different combinations of sensors and robots, as well as see how well they do in the different types of worlds that you're able to create. In particular, we have tiles, these SubT tiles, that you can compose your own worlds. You can mix and match and structure everything from, as you can see here, a two-story sided building that you can go on the bottom floor and have to climb stairs to get to the second floor, as an example, or tunnel-like environments with twists and turns, or caves that have inclines that are pretty challenging for many robots to accomplish. And we also have those 3D models of the artifacts themselves. So things that you're working and looking to find with your physical robots, you can emulate and simulate here in the synthetic worlds using the assets in the SubTech repo. The other thing here is that we've invested greatly in the SubT simulator. This is leveraging Ignition Gazebo by our friends at Open Robotics, tightly coupled with Robotic Operating System. And we're leveraging a lot of this infrastructure in the cloud, meaning teams are able to develop locally with this access to the simulator. But at the end of the day, the competitors need to submit their standalone Docker containers that get run in the cloud across a number of these hidden worlds that these robot solutions have never seen before. And we get to robustly address and explore, evaluate how well they do in those settings. So that's really what these the simulation environments are great for. We've been able to build out that cloud-based simulation capability across multiple nodes where robots are represented by their own respective GPU instances. We can scale the number of robots as well as the size of the environment to those that might be otherwise hard to accomplish in the real world. And we're taking advantage of that next generation Ignition capability, kind of following on where Gazebo is and taking advantage of a lot of the breakthroughs in game engine technologies to allow for us to render these highly realistic environments. We can take advantage of access to that SubT simulator. I encourage you to go take a look at the wiki, but that SubT virtual portal houses all the information you need to get started with the SubT simulator, as well as the SubTech repo. And so just to highlight where we're going with the cave circuit, we have a number of things that I'd love to share with our group here. We have new robot models here. And what's exciting about this is these are robots that we saw actually go onto the courses during the urban circuit. We're able to take photogrammetric scans of these robots, kind of render them into CAD, turn them and release them with their respective controllers. And now they're part of the SubTech repo where any virtual competitor can go and add them to their robotic team and test them out. We're including everything from multi-rotors to tracked robots, to segmented robots, to even the quadruped there. And what's exciting about this is now we get to see the virtual and the systems competitions get one step closer as we start to understand what technology works and what technology doesn't often. Another feature that we've just recently rolled out is the use of marsupial robots. This is a capability we think will continue to play a role in a lot of these really diverse environments where you have ground robots ferrying in air robots, and in particular, we've been able to demonstrate this feature now as a type of robot platform, combined robot platform you can basically check out in the SubTech repo and build solutions around where the robot can basically kangaroo in an aerial platform that might be able to help you out reach those hard to see or hard to reach high locales. On the bottom right, we have introduced the comms breadcrumbing capability. Some of these ground robot platforms that are available to you in the SubTech repo now can drop half a dozen to a dozen comms radio breadcrumbs that allow for you to extend into these long distance courses and still maintain comms back to your base station, which is, again, how you score points. You can only score points. You only get credit for those reports that you make it back out to that base station. And so these comms and breadcrumbs are enablers of that capability. And then finally, one of my favorites, new features here, are the dynamic environments that we've now introduced into that simulation environment. One of the biggest challenges, of course, is what happens when the world around you changes. This poor robot has come through that narrow passageway, and we now see it's triggered a rock fall that's blocking its way back the way it came. So what does this mean? It means that these robots now need to be able to adapt and find new ways around this environment. And these kind of dynamic obstacles and other conditions in these challenging environments are the types of things we're eager to solve using advanced autonomy and perception capabilities that our virtual competitors bring to the competition. And so for those of you who are interested in being a part of the SubTChallenge, I encourage you to come register your team, whether you want to compete on the systems and or virtual competitions, or whether you're a one-person team or a massive university group or a company that'd like to showcase what you're made of. I encourage you to come and join along. But there are many different ways that you can be a part of the SubTChallenge, even if you're not quite ready to dip your toes into the competition ring. I think there are many different ways you could contribute new robot models. This, I think, is great for example, those companies or research groups that have robotic systems that they think would be a major contributor to the problem, to the underground mission, and they wish to offer that up to other competitors, to make use of on their robotics teams. Or perhaps you're a sensor or a payload manufacturer and would love to see that novel sensor or novel comms device play a role in the SubTChallenge, really to showcase what it's capable of doing. And so developing those novel payloads for that simulation environment could be a great way to go. If you're more into building worlds, if you're Minecraft type of a person or whatnot, we have those tiles that I mentioned where you can assemble your own creative creation and think about what it means for robots to try to navigate those inclines or those intersections or those drop-offs, and understanding what makes these types of environments so challenging for robots, and then thinking about the types of technologies that'll help us overcome those types of challenges. And then finally, if you really just want to get a feel for the SubT simulator as well as the types of assets that are available, I encourage you to check out the Hello World tutorials that Open Robotics has put together. Everything from just how to get started, getting your environment set up, all the way to walking through the simultaneous localization and mapping type solutions, the types of robotic perception, for example, using DarkNet to train on the artifact detection models, as well as making use of navigation packages available in the ROS navigation stacks to be able to help you drive your robots around and get you to the point where you can field your own SubT virtual competition solution submission. And so finally, I really welcome, I think that's one of the most exciting things about the SubTChallenge is that all of us can really appreciate, I think, how hard it must be for these robots to conquer these underground spaces. So if you want to stay plugged in, I encourage you to join our Discourse community forum. That's the SubT community forum where You can interact with other folks, ask questions, whether it's about the rules or if you want to showcase some of the resources that you have available. Maybe you have a data set that could be really useful to our competitors. We have a teaming resources category there that you can go and join in. We, of course, have our SubTChallenge YouTube videos that I encourage you to take a look when you get a chance. It's a lot of fun to see what robots are doing in those underground settings. And of course, a couple of different ways for you to engage with DARPA as well as the SubTChallenge. My team is eager to engage with you and certainly welcome questions and curiosity across the board. And with that, I, again, really appreciate the opportunity to share this afternoon with you and look forward to any discussions or questions that you might have. Thank you very much, everybody.
Thank you so much. It was a very informative presentation, and there are a number of comments as well stressing that, and a number of questions that you may have already answered, but I do think it's worth perhaps going back to that. We were just talking before, there were a lot of questions submitted as part of the registration that fell into roughly 3 categories, really. One is for those that are interested in participating or engaging in some way with the simulation or other aspects of the challenge and are just looking for introductory information. And then there are people that are more deeply involved that have more specific questions regarding aspects of the competition. And then there were perhaps general information questions, perhaps more spectator type, which I can certainly relate to, around what is coming up next and how can we stay involved in seeing what's happening. But I think let's start with the individual or new team participation. How are there obstacles or limitations? Is it possible for one person to succeed in the Darpa SubTChallenge?
Yeah, great question. That's what's so much fun here is that whether you're a single individual or you are a competitor from around the world, you're welcome to participate in the SubTChallenge. We have numerous participants, teams comprising members from all around, whether you're part of a middle school or a high school or a college team, or if you're a bunch of folks that want to work on the weekends as your weekend warrior roboticists, you're all able to and welcome to participate. And I think that's where, whether you're on the systems competition or the virtual competition, what you bring is that energy and innovation. And so qualifications are still open. These are opportunities for those who are interested to participate in the SubTChallenge, whether the systems or the virtual competition. That's still open for the upcoming cave circuit. You need not have been in any of the prior competitions to compete in the cave, nor even in the final event, should you be interested. And we've had instances where some of our winners from the tunnel and urban circuit was a one-person team who just had a passion for robotics and has a history of working in these types of challenges. And so, I think there are many different opportunities, and I encourage you to come take a look at our webpage for some of the details. You can register your team and ask more questions about how to get started.
That was very inspiring to know that a one-person team, effectively, as you also talked about weekend warriors, I believe this is a person who really did this outside of a full work week too, but now was able to be very successful in at least so far. There was another question that hasn't come up yet, but in the pre-questions, if you're a single person but you want to join a team, is that something that, do you have to set that up yourself, or is there some form of kind of matching that's part of the Darpa process?
Yeah, that's a great question. So that SubT community forum is an excellent place to try to reach out and see. All of our competitors are already on there because that's where they get a lot of the good news or the announcements, and additional questions get answered there. And so that's a place where we actually have a category just for teaming. If you have a capability that you'd like to bring and you think a team could benefit from it, I encourage you to post a little bit about yourself. If you know anyone from those teams, many of them, I think, have really embraced what we're interested in here, which is building a community around our passion for breakthrough technologies. And I'd say, to give you an example, one of our teams started off with that one person competitor and engaged with the local middle school to build a ground robot and the local university team robotics group to flesh out his team at the urban circuit. And so we see that kind of teaming happening quite often. I'll encourage you to reach out. We don't have a mechanism by which we'll explicitly do any matchmaking because really every team has its unique capabilities and needs, and that's where any interested partner has an opportunity to shine by showcasing what he or she brings to the table.
That's great. So really it's an organic process, but the communication platform is there, and you have the opportunity to find teams that work in the same way that you do, and so on. So that's great. You raised a couple of interesting points as well. In fact, one of the questions that I want to make sure we don't forget that came up first, Ari says that you've kind of answered that already, but is the simulation environment available for other research projects?
Yeah, absolutely. That's one of our major commitments here, I think, is to make sure that this SubT simulator is capable of and has the feature set that's going to be interesting to researchers everywhere. So all of this is open source. You can get all of the code as well as all of the documentation that we've spent a lot of time making sure is up to snuff. All of that's available online and open source. It's part of our ongoing engagement with the Open Source Robotics Foundation to bring that next generation simulator as well as all the capabilities we're investing in out there and share that to the research community. And then on top of that, a lot of the great things that we're doing in terms of sharing the data sets that we've gathered. So many of the venues that we've gone to, we have ground truth data that we've conducted survey grade, professional grade surveys, as well as laser scans. And so that's available for your own research now, publicly available, downloaded. They're rather large data sets, but now you can basically go and work with those point clouds yourself and see perhaps how well your solution would have done in those types of environments. And the other cool thing is many of the teams are now releasing a lot of their code packages right back into open source, releasing their data sets. We get many occasions where one team is sharing with other teams those data sets because, quite frankly, it's hard to get training data for your object classifier in representative underground environments. And so the sparsity of data means we probably need to work together. And so many of the teams have shared their data sets, their annotated labeled data sets, just to help each other out. And so a lot of those are also shared and public and open, and even separate from the competition. These simulation environments and all of that is available for individual research as well.
That's great to hear. Are you aware of any examples at this stage, or is it still a little bit early?
Yeah, I think we've heard a couple of cases where folks are interested in seeing the role of, for example, tying some machine learning hooks into the ignition simulation engine so that you can accelerate some of that learning. And I think, doing that, getting in early with ignition kind of growing right now very quickly gives you an opportunity to develop those hooks that are better tailored perhaps to your research. There are others that are really interested in understanding how to present information of these really complex three-dimensional environments. It's one thing to show floor plans to a first responder, but if you can show them this kind of immersive environment, what can that do for you as well? And so I think there are some folks interested in using the virtual environment as a user experience / training environment potentially as well. So I think there are a number of places where folks are starting to see the advantages of tying next generation's robotics simulation with the applications of interest.
That's wonderful. And you mentioned as well that people can submit their robots as or simulations of their robots, and also simulations of sensors and payloads. One of the things, I'm not saying that this is not a complicated challenge already, but I didn't see much in the way of manipulation happening at this point. Are people submitting robot arms or working with that, or deploying any forms of manipulation yet?
Yeah, fantastic. And we know there's a lot of activity in our robotics community in manipulation. So the scope of the robotics challenge was to leverage humanoid robotics that did have manipulation studying in there. And so there is a lot of great work that came out of there that spawned a lot of great research. And so the scope of the SubTChallenge is really more about that, how do you conquer the environment that's so overwhelming that while manipulation could be potentially valuable, there are many other technologies that still need to come together in a meaningful way. And so I welcome any solutions that make good use of manipulation, whether that's picking up after yourself, right? Leave only footprints. So maybe you pick up your own comms breadcrumbs on your way out, or maybe there's a way that manipulation can help you sift your way or probe to see where to move next. I can imagine some really innovative solutions, but I think the scope for the SubTChallenge is much broader than that. And thus far, we haven't seen manipulators come to bear, but that's not to say that one wouldn't be able to find really great uses of them.
We had a very, yes, they can become an addition with marsupial robots, and I love that term for robots cooperatively, I guess, piggybacking on each other. There are a couple of specific questions that have come up that are relating to training data and to the timing of the cave circuit. So Les is interested, I think, in terms of his startup being able to contribute labeling or to assist with training data. And he was having a bit of trouble in the GitHub finding exactly what he was looking for, and perhaps we can do some follow-up offline to help with that. I saw a couple of other companies had expressed their willingness to work with the SubTChallenge, I think Eclipse as well, in being a middleware for working with Ross. And I know that there are some people from sensor companies currently on the call. I'm sure that if their sensors are not already in the simulation, they will be soon. But there was a very particular question from Brett as to, is there a date for the cave circuit yet?
Yeah. So we haven't announced it yet, but I can say stay tuned. We'll be announcing when the cave circuit explicitly will be, as well as all the qualification deadlines that come with it. But I can tell you that that announcement is forthcoming here shortly. What I can say, however, in the fall of this year, we'll be pretty excited to tackle the cave environment, which I'll tell you from personal experience of scouring different caves all throughout the country. The diversity that I've seen in cave environments is one that I am so excited to see robots face. I think that's going to be one of the really exciting opportunities for the competitors and the robotic systems that both in the virtual and in the system competitions. I think we have a great cave circuit lined up.
Wow. And obviously it's been a real challenge working with this complex, both physical and virtual competition at the time of pandemic. And I know we all want to hurry up and get more robots for disaster scenarios, but it must make it very difficult to plan around doing the fall cave circuit as well.
Yeah, I mean, I think one of the amazing things as we think about impacts, that virtual competition has really shown an opportunity for us to develop technologies while remaining safe and healthy, and of course, we'll always have the challenge of sim to real, where getting out in the real world is going to drive a lot of our technologies and the design of those technologies. But there have been so many really great opportunities for insights into the technologies, the tech gaps that we still have by leveraging the virtual infrastructure for the SubTChallenge. And so I think being able to have both systems and virtual competitions and having the virtual infrastructure and the investment DARPA's made to really bridge that gap has helped out a lot of our teams as well as the community in terms of what we're developing for and how to accomplish our goals here.
Yes, I have to say thank you for investing into that simulation environment. I think it just made such a difference with the original Darpa Robotics Challenge, and it's going from strength to strength. Now it is, as you said, there are still sim to real challenges, but it's propelling development significantly faster than the isolated heterogeneous robotics developments that we see in physical world. So, I think it's creating a very strong competitive cohort. I'm certainly hoping that I will get to come and watch the next round of the challenge, and definitely the finals. But at the same time, the way that it's being done online is starting to become arguably better than what I could see in person. Thinking of how the in-person Darpa Robotics Challenge finals were done in Pasadena, in California. It was a great experience, but you really couldn't see a lot of effectively how the sausage was made unless you went online. And clearly with these environments, it's kind of obvious that they're difficult environments for people to see. So watching the event in person starts to become really secondary to watching the event in a virtual fashion.
Yeah, we're really excited about SubTV, as we call it. This is a chance for you to watch the feeds for both the systems and the virtual competitions, really trying to bring those environments to our viewers and the public. I think a major reason for that, of course, is safety. But I think one of the challenges, and we have on our YouTube channel the walkthroughs, the course walkthroughs, that I encourage folks that are interested to take a look at, because it really showcases the little things that could trip up most of our robots. Everything from the curve, or the way the stair is designed, or the vertical shaft and the way the shadows or the puddles, or I think those are all the types of things that these environments really offer, and we're trying to showcase that. Because for many of us on the call here, you may very well have personal experience where your robotics systems might fail, and we're really trying to showcase that the underground you might not have thought of in your everyday discussions, but it turns out that there's so much of our world that needs and works in the underground setting, or similar technology challenged environments. And so and as always, we are eager to take suggestions if there's something that you want to see. Our hashtag SubTChallenge is available for suggestions and inputs, because we love hearing from what people are interested in.
That's wonderful. And there's a finishing question that is beautifully open-ended, which is, as you just pointed out, in fact, learning the models of the environment is crucial for success, and learning internal models is what Aries is talking about. Is DARPA going to pursue research on this or in similar fields? And that's a bit open-ended as to what they are in robotics and AI moving forwards.
Sure. So what I can say is DARPA is always interested in great ideas. whether it's in the context of SubT or in other arenas where autonomy and robotic systems is going to play a very valuable role. And so in the context of these types of learning models and some of the basic research, there are a number of different offices at DARPA, including my own, that would find those types of projects quite interesting. And we have a mechanism, we call them seedlings, because we're really interested in understanding the nuances of what can grow into a much broader impact. And so we have a broad agency announcement that we welcome white papers and executive summaries, and this is a way to get your idea in front of one or more program managers, and could be something that is something that gets picked up to get studied further. Specifically about learning these types of models of environments, I'd say there's a really distinct opportunity for SubT, because the types of models that one might create for these underground environments could be markedly different than, let's say, pedestrian traffic modeling or daytime highway traffic, or whatever the case might be. They're very different when we're talking about the environments in these settings, and I think there's a rich opportunity there. I'll give you one example. If you know that a building has a lot of rooms in it, do you want to go and figure out how to search all the hallways first, or do you want to stop and search each room first, right? And so that's a question that robots right now still require maybe some human decision making to guide them. But wouldn't it be interesting if robotic systems could intuit what the environment is asking them to do and find the solutions that will be best appropriate for the mission at hand? And I think there's really great opportunity, and I can assure you many of the competitors out there would love that research in hand as well. So that's another opportunity I encourage you to take a look at. Thanks for the question, Harry.
Yeah, that was a wonderful answer. Thank you very much. And as said, it's taken it from the Darpa SubTChallenge to the what's next. So I think that was a wonderful point to finish on, and a very, very rich presentation and discussion to date. Thank you so much. And we'll make sure that everybody has the links that they need to follow up, and we'll remain in touch. I'm looking forward very much to the next iterations and to the announcement of the date of the CAVE circuit coming up. Thank you.
That's great. Thank you. And thank you, everybody. Have a great day.